Standard temperature and pressure. So there are a couple of values that are associated with this. So no, there's no specific question regarding standard temperature pressure STP. It is something that you're going to have to recognize, and I believe that is also on the back of your laminated sheets for the periodic tables. So standard temperature is 0 degrees Celsius or 273 Kelvin. Standard pressure is 1 atmosphere. Standard molar volume of gases, so in 1 mole of a gas there's 22.4 liters, and this is occurring at standard temperature and pressure at STP. So if you see a question that says that, you're going to have to think about using these values somehow. What is the volume of 30.8 grams of CO2 at STP? So what we're going to use is we're going to use Avogadro's law for this. So convert 30.8 grams to moles, and then use Avogadro's law and the fact that 1 mole of CO2 occupies 22.4 liters at STP. So let's remember that Avogadro's law is V1 N1 equals V2 N2. These two are grouped together. 1 mole at 22.4 liters, so we can make this one my N1, this my V1. And we're trying to find the volume, so this is going to be my V2. After you convert this to moles, this will become your N1 eventually. Do not plug in 30.8, you're going to mess it up. V2 N1 equals V1 N2. So then let's solve for V2. Okay, so let's do this really quick to solve for N1, which I haven't done yet. So your molar mass is 12.01 plus 2 times 16. So my number of moles of CO2 is going to be 30.8 grams. So then it's 44.01 grams on the bottom, and that equals 1 mole of CO2. 30.8 divided by 44.01 equals 0.6998 ... So this is my N1. What you can do to help keep this number accurate without rounding yet, plug in your numbers. 22.4 liters on top. I'm sorry, this is N2. I apologize. So then you take your N2, which is the 0.6998 ... divided by N1, so 1. So 0.699 whatever times 22.4 divided by 1, just to be thorough, it is 15.676. So then it looks like we have 3 sig figs, so 15.7 liters. Okay, the combined gas law, combination of Boyle's and Charles's laws. So it kind of takes all your laws and puts them together, well, these two of them, to make a third one, hence the war on the bottom and endgame. So similar to before, P1, V1, T1, pressure 1, volume 1, etc. So it's P1, V1 divided by T1 equals P2, V2 divided by T2. So what I suggest for this is just paying attention and do not plug in your numbers yet until you rearrange your formula. Because if you try to plug in your numbers first before you rearrange, you might get a little confused. But if it works for you and you get the right answer, then that's okay. But I'm just saying from experience, try to rearrange the equation first and then plug in your numbers afterwards. First question, a weather balloon has a volume of 500 liters at ground level where the temperature is 294 K and the pressure is 749 millimeters of mercury. What would be the volume of the pressure of the balloon when it reaches an altitude where the temperature is 244 K and the pressure is 547 millimeters of mercury? With these laws, except for temperature, as long as you're consistent, you're okay, except for the ideal gas law, which we'll talk about next chapter. However, your temperatures have to be in Kelvin, okay? So you have to keep that in mind. So what I'm going to do is I'm going to do these in different colors so you can kind of see where the numbers are going, etc. So let's do 500 liters. That is my volume 1. Temperature 1 is 294 K, and pressure is 749 millimeters of mercury. What will the volume be? So I'm trying to find the second volume when it reaches a temperature of 244 K. And the pressure is this, 547. This is my P2. So P1 V1 divided by T1 and then P2 V2, oops, wrong color, and then divided by T2. Okay, so we're trying to solve for the one that I messed up on in terms of color. So that's rearrange equation, so cross multiply. T1 P2 V2 equals P1 V1 times T2. Okay, so I'm trying to solve for V2 right there, so I got to divide by that on the left side. T1, then P2. So then these numbers cancel out. Oops. And you end up with V2 by itself. Then you can plug in your numbers finally. P1 is 749 millimeters of mercury. Volume 1 is 500 liters. T2 is 244 Kelvin divided by T1, which is 294 Kelvin. And then P2 is 547 millimeters of mercury. You're now left with just liters by itself in terms of units, because now the units all cancel out except for liters. So now let's do our math finally. 749 times 500 times 244. You end up with 9137800, then divided by 294 times 547. 160818. This equals 568.207539. So we can do, let's do, for this one, because it's a little confusing, we can do 1 sig fig, and that will make it 600 liters. Or if you happen to do, since that's 568 liters, I'm okay with either one in terms of this stuff. Last question for combined gas law. 500 liters of a gas in a flexible wall container are prepared at 700 millimeters of mercury and 200 degrees Celsius. The gas is placed into a tank under high pressure. When the tank cools to 20 degrees Celsius, the pressure of the gas is 30 atmospheres. What is the volume of the gas? So, same law. I won't do the colors for each one because that took a long time. Let's just do this. So, volume 1, pressure 1, temperature 1. temperature cools down to 20 degrees Celsius. That's my T2. My new pressure is 30 atmospheres, so P2, what is my new volume? So P1 V1 over T1 equals P2 over T2. Solving for V2, we cross multiply. So P1 V1 T2 equals T1 P2 V2. Divide both sides by T1 P2 to cancel it out to get V2 by itself. So the thing we need to do first is we got to convert our Celsius to Kelvin. So my T1 is going to be 473 Kelvin. 20 plus 273 for my T2 is 293 Kelvin. P1 is 700 millimeters of mercury. V1 is 500 liters. T2 is 293 Kelvin. My T1 is 473 Kelvin. And then my P2 is 30. Ooh, I didn't realize that. So 30 atmospheres and millimeters of mercury. Got to make sure they're both at the same unit. So that's a good thing. I just caught that right now. So make sure you guys catch that as well, okay? So we can convert to either one. So 30 atmospheres. 1 atmosphere is 760 millimeters of mercury. So 30 times 760 is 22800. 700 times 500 times 293 divided by 473. Putting that in parentheses, 473 times 22800. End up with 9.5091 something liters. This equals, let's do 9.51 liters. Box it in.